Hello. So this is the first video in a new series where we will delve into the Boeing 737 NGX made by PMDG. This add-on for FSX and Prepared is widely regarded as being one of the most comprehensive add-ons available for flight simulation and one of the most faithful recreations of a real 737. In this video, we're going to take a look around the flight deck and identify the location of each switch and panel and talk briefly about its purpose to prepare you for future tutorials. Before we do that, there's a couple of disclaimers that I need to get out of the way. Firstly, I am not a real pilot, therefore I will not be providing a lot of specific technical details about various systems. I will talk about the fundamental details of various items, but if you want to know all about the specifics of something in this aircraft, I would highly encourage you to conduct your own study. PMDG have provided a lot of detailed documentation with this aircraft, and also some clever online research will provide answers. Now, because I'm not a real pilot, this video and the ones that follow will be based on my understanding of the documentation and the study that I have conducted. I know that there are many videos about this add-on, and I know that there are other YouTube videos made by real pilots who fly these aircraft every day. So some of the things I might do differently to them, I might make some mistakes, I might explain something incorrectly. Please be mindful that I am merely an enthusiast trying to help other passionate flight simmers. I am not a professional pilot. Lastly, this is a very comprehensive simulation of the Boeing 737 NG aircraft. This aircraft will be overwhelming to someone who is completely new to flight simulation. Therefore, I would highly recommend that you gain some good fundamental knowledge of aviation, which will put you in good stead to fly this aircraft. I have included a playlist of videos that I have made over the past few years, which should provide you with everything you need to fly this aircraft with confidence. You can click the little eye icon in the top corner of this video, or check the link in the description to find that playlist. Anyway, without further ado, let's jump in and start learning the PMDG Boeing 737 NGX. So the easiest way I think we should approach this is to simply start at the top and work our way down, starting with the overhead panels. So looking up, you will find that the overhead panels are split into two main sections. You have the aft overhead panel and the forward overhead panel, and you can get a good view of these by right-clicking and selecting the view from the menu. So let's take a closer look at the upper or aft overhead panel first. So you're not going to spend much time looking up here. Usually you only look at this panel to do a couple of actions and check a couple of things when starting the aircraft from its cold and dark state, but let's run through it anyway. First on the left here we have the LE devices panel, which shows the deployment of flaps and slats along the leading edge of each wing. As the flaps and slats are extended, different parts of the panel light up to indicate that they are moving with the yellow lights and in position with the green lights. Underneath that you have the PSEU light, which is a fault light for the proximity switch electronic unit. This is a system which checks the position of various moving parts in the plane to make sure they match what has been selected by the pilots. For example, if you select flaps setting 5, this system makes sure that the flaps are moving to position 5 and not position 10, for example. Next we have this switch with a red guard. Just a note on switches like this. To manipulate the switch, simply left or right click on a guard to open it. This will then allow you to left or right click on the switch underneath to change its position. There are a few guarded switches in the cockpit, so be aware that when the guard is closed, it will automatically move the switch to its correct position for normal operation. Now, I couldn't find any reference to this switch in PMDG's documentation, but a quick search on an online forum suggests that this may be a switch related to an onboard Wi-Fi system in the plane. Something which I doubt is modelled in FSX, so this switch may not have any function in the sim. The next section is the IRS display unit. The IRS system is part of the overall flight management system and provides information such as the aircraft's current pitch, roll and yaw, amongst other things. You can use the outer knob here to do several things like test the system. TK/GS shows the true track in the left side of the display and your ground speed on the right. PPOS shows your present position with accurate latitude and longitude coordinates. The coordinates here are displayed in the degrees decimal minutes format. So in this example, they read 57 degrees, 32.4 minutes north, and 4 degrees, 3.7 minutes west. HDG and STS show your true heading on the left and the system status code on the right. The smaller knob here simply changes the brightness of the numbers in the display area. This switch below is the system display selector and allows you to select either the left or right IRS to obtain information. The keypad will allow you to manually enter the present position or magnetic heading if the IRS system cannot obtain this information automatically. Below that section you will find the IRS mode selector unit. So there are several indicator lights here which indicate what's going on with certain systems. First is this GPS light, which will light up when there's a problem with the GPS sensor units. Beneath that you have several lights which relate to the IRS status. I'll talk about these in a little more detail when we talk about setting up the IRS system. Below that you have the mode selector switches to switch between the different IRS modes. In the middle here we have the service interphone switch, which allows the pilots to communicate with ground crews who have headsets plugged into the aircraft. Below that is the dome light switch, which switches on a large light which illuminates the whole cockpit. The next panel we have here is the audio control panel, which allows a pilot to change the configuration of the plane's audio setup. This top row of buttons allows you to choose which radios to transmit on, so VHF radios 1, 2 and 3. Next are the HF or high frequency radios. FLT I believe is the flight interphone system, so pilots can communicate with flight attendants. SVC is the service interphone system to speak to ground crews, and PA is the passenger announcement system. The buttons with the arrows allow you to select which systems you receive audio on. In the real aircraft you push the button and it will light up, and you can also rotate them to change the volume. However, in the sim you can only turn them on and off. The top row relate to the same systems as before. The second row, as you might guess, are radio navigation systems, so you have your nav 1 and 2, ADF 1 and 2, I think MKR is the approach marker audio, and the last one allows you to redirect audio from one of the systems to the loudspeakers in the cockpit. Beneath all of that you have more switches. The first one is a push to talk switch. Push up to talk over the radio to an external radio station, and push down to talk over an intercom system inside the plane. The next switch is a microphone selector. Normally this is set to boom to use the microphone on the pilot's headset. However, in the event that the pilots need to wear their oxygen masks, you can change the microphone to use the one built into the oxygen mask. This selector is a filter switch which allows you to receive voice-only audio, range audio, which is the Morse code identifier that nav aids constantly emit, or B, which is both. The last switch here lets you operate the radios in a normal or alternate mode. The next panel is an engine panel which displays some information. The first items are reverser lights which normally light up when a fault has been detected. Next you have these two EEC buttons which stand for electronic engine control. This system automatically regulates each engine, so it's pretty good to have it on. The engine control lights either side of the EEC buttons indicate if there's a fault with that system. Next you will find an oxygen panel. Crew oxygen displays how much oxygen is available to the pilots with their oxygen mask systems. Pass oxygen is a switch to enable the oxygen masks above a passenger seat to drop down. In the normal position, an automatic system can detect a drop in cabin pressure and release the masks automatically. If that fails for any reason, pilots can manually release the masks by moving the switch to the on position. There is also a light to indicate when the system has been activated, either automatically or manually. Under that you have a backup set of lights which indicate the position of the landing gear. These will light up when the landing gear is down and locked, and will be unlit when the landing gear is up and stowed. There's no amber lights to indicate that the landing gear is moving between positions. Moving over to the right side, we have the flight data recorder switch. The flight data recorder, of course, records a lot of data from the aircraft and is active anytime the plane is in flight or on the ground with at least one engine running. There is also an off light to indicate a problem with the system. Next to that you have the Mach airspeed warning test. Simply, these are two buttons to test the warning sounds in the cockpit, like so. And lastly, you have the stall warning tests, which will activate a stick shaker for the captain's control yoke and the first officer's control yoke. When the aircraft is approaching a stall, this system activates and will shake or vibrate the control yoke to provide tactile feedback to the pilots that a stall is imminent. So that's the upper or aft overhead panel. Let's continue now with the forward or lower overhead panel. So there's a lot to take in here, but what I'm going to do is divide this panel into 5 columns like this. And what we'll do is we'll start on the left and work our way down, then move across and down again. Moving around the panel like this is a technique that pilots do to work through and check the numerous switches and indications in a cockpit. This technique is called a flow, and this specific way of flowing through the overhead panel is something we'll do in a later video when we begin preparing the aircraft for a flight. But let's continue learning about what each switch on this panel is. First, in the top left, we have the flight control panel, which controls the systems responsible for moving the flight control surfaces, such as the elevator, ailerons, and rudder. There are 2 switches for 2 hydraulic systems, A and B. When the switches are guarded, they are in the on position. If there is an issue with either of the hydraulic systems, the low pressure light beneath the switch will light up. Under that, you have 2 similar switches for flight spoilers. Again, the guards covering the switch means that it's in the on position. At the bottom, you have the yaw damper switch, which helps the rudder operate. It mainly prevents an aerodynamic effect called the Dutch roll, where an aircraft is not stable in flight. The lights will come on if the yaw damper is either switched off or not active. Up at the top right of the panel, you have some standby hydraulic system lights to indicate the status of the standby hydraulic system. Under that are a couple of switches for the alternate flaps system. The red guarded switch is the alternate flaps master switch. Normally it's in the off position, but if you need to activate the system, you would need to move the switch to the arm position. Then you can use the second switch, which is the alternate flaps position switch. This switch is normally in the off position, but you can push it down to extend the flaps and up to retract the flaps. Then finally, you have 4 lights which indicate a problem with a control subsystem in the aircraft. You have lights for the elevator feel system, the speed trim system, the Mach trim system, and also the auto slat system. On to the next panel. Here you will find multiple data source selection switches. So you may have noticed that this aircraft has 2 versions of many different systems. There's 2 IRS systems, 2 GPS systems, 2 hydraulic systems, etc. This provides redundancy or a backup in the event that something goes wrong with the system. These switches all tie into the flight management system and allow you to choose where the flight management system gets its data from. The 3 switches here relate to the VHF navigation radios, the inertial reference system, and the flight management computers. Normally, you would leave these switches in their middle or normal position. However, if a problem occurs with one of these systems, you may need to change the source of one of them to continue flying. Underneath those are a couple more source selection switches. However, these relate to the main displays in the cockpit. This takes information from various sources and sends it to both pilots' displays, and similar to the switches above, they are normally left in a central auto or normal position. If an issue occurs where a display is not receiving the correct information, then again you may need to change the source here. And then below that you will find the fuel control panel. So first, in the middle here we have a fuel temperature gauge, pretty self-explanatory. Either side of that we have 2 lights relating to the engine valve and spar valves within the fuel system. So these are 2 valves which sit in the fuel lines between the engines and the fuel tanks. When these lights are on, that means that the valves are closed, which means that fuel is physically blocked from reaching the engine. The next couple of lights here are the fuel filter bypass lights, one for each engine. In the event that a fuel filter becomes clogged up, then the fuel system can skip the filter and send fuel directly to the engine. This will light up when that happens, and it normally indicates a problem with the fuel filter. In the center here we have the crossfeed selector and associated indication light. Just so we're clear on what a crossfeed is, normally in an aircraft the left side fuel tanks will work with the left engine, the right side fuel tanks will work with the right engine, and both sides normally work independently from one another. Now sometimes there may be an issue with an engine or one of the fuel system, so what the crossfeed allows you to do is connect both fuel systems to allow fuel to flow between both sides of the aircraft. To do this in this aircraft, you would flick the switch so that the bar on the switch itself is lined up with the grey lines on the panel. This means that the crossfeed valve has been set to open, and this is confirmed with the blue light above it. To close the valve, move the switch so that the grey line is broken and the light is off, confirming that it's closed. Now there's an important little detail here to note. When you move the switch, watch the light very carefully. At first it's a bright light, and then it goes a little dimmer. When the light is bright, that means that the valve is actually in transit, it's actually moving. When the light goes dim, that means that the valve is now fully in the open position. Next, you have a bunch of fuel pump switches and indicator lights. In the 737, there are 3 fuel tanks, one in the left wing, one in the center of the aircraft, and one in the right wing. Each tank has 2 fuel pumps to send fuel from the tank to the engines. In the 737, it's better to have fuel in the wing tanks rather than the central one, so on shorter flights, fuel will be loaded into the wing tanks first. For longer flights which require more fuel, the wing tanks will be filled up first, then the central tank after. Next, we simply have fuel pump switches for the center fuel tank. The low pressure lights will come on when the output pressure from the fuel pumps is low, which typically occurs when the tank has run out of fuel, but it could also indicate a fault with that particular pump. One thing to note, when one of these low pressure lights come on, the master caution lights will also come on to alert the pilots. Beneath that you have the left and right fuel pumps, again 2 pumps for each tank. So the basic rule when flying this aircraft is that you have all 4 wing pumps working all of the time. If you have fuel in the central tank, you would also switch on the central fuel pumps. The central fuel pumps are actually more powerful than the fuel pumps in the wing tanks, so even when you've got all 6 pumps turned on, the center fuel tank will drain quicker than the wing fuel tanks. Then, once the central tank has drained, you can turn off the center fuel pumps. Okay, so let's move up to the next column of panels. I really hope I haven't bored you to death yet. First, up at the top is this cockpit video system switch, which is actually one of the few things that you cannot click on in this aircraft. So most of this column relates to the electrical systems within the plane, so let's start working through it. At the top we have the AC and DC metering panel. Now I'm afraid I don't have a good understanding of electrics, so this is going to be a sort of basic overview of this area. At the top we have a display window which shows different pieces of information relating to the AC and the DC power systems within the aircraft. On the left you have a DC ammeter and voltmeter below that to measure the DC amps and volts. In the center and right side we have the AC ammeter and voltmeter, and just above that is the frequency meter to monitor the frequency of electricity within the systems. You can monitor different electrical systems by moving these source selector switches. On the left you can select different DC meters. Notice that as I change the source, different numbers pop up in the DC sections of the display. On the right is the AC meter selector, and again, different numbers pop up depending on which AC source is selected. In this example, the plane is on the ground, the engines are off, and the ground power unit is connected and supplying the aircraft with electrical power. Just underneath the display are a couple of indicator lights which indicate a problem with their associated system. So you have a battery discharge light when the battery power is low, a transformer rectifier unit light when there's a problem with one of the transformer rectifiers, and that is a system which converts AC power to DC power. The last light is a general electrical fault light to indicate a problem with a DC power system. Finally, there is a maintenance button, but that's only used by ground crews. The guarded switch here is the battery master switch, and next to that are two smaller switches. The first is to switch power on or off for the cabin and utility systems, so these are things like cookers and water heaters in the flight attendant galleys. The other switch is to switch power on and off for the in-flight entertainment or passenger systems, so things like passenger TVs or power outlets near passenger seats. The next panel is the generator drive and standby panel. Let's start with this guarded switch, which is your standby power selector. This normally sits on auto and you won't need to move the switch unless there's an electrical fault which needs troubleshooting. Above the switch is an indicator light to show when standby power is off or when there's a fault with standby power. To the left and right of that you have these generator drive lights. So in this aircraft, electrical power is usually supplied by electrical generators built into the engines. So when the engines are running, they spin a generator and produce electricity for the aircraft. If there's a problem with one of these generators, this light will come on. When the engines are switched off, it's normal for these lights to be on, because the engines are not running, therefore the engine generators are also not running. You also have these two red guarded switches. If there's a problem with an engine generator, they can be disconnected from the engine. Now flicking these switches is a last resort action, because they will physically disconnect the electrical generator from the engine, and this is an action that you cannot reverse. You cannot reconnect the electrical generator once it's been disconnected. Only a ground maintenance crew can do that, and even then, they would have to pull the engine apart and install a brand new electrical generator. Moving down to this last panel, the first thing we have here is a ground power availability light. So if a GPU is connected and supplying power, this will light up. Pilots can then use the switch below the light to accept ground power and switch the aircraft's electrical systems over to the ground power source. Next we have a couple of components relating to the AC power system, and again my understanding of this area is a little hazy, but here's what I think is going on. In the middle here we have a bus transfer switch. So the transfer bus is a system which switches between different electrical AC sources to ensure that the aircraft's electrical power is not interrupted. So it's responsible for switching between ground power sources, APU power sources, and engine generator sources. Normally you leave this switch in its guarded auto position. Either side of the switch we have indicator lights to show when the transfer bus is off, and next to that you have two source lights which light up when the transfer bus is not receiving any electrical power in the first place. Underneath those you have your Gen 1 and Gen 2 systems, so these are the engine generators, also known as IDGs. So when the Gen off bus light is on, that means that the generators are not active and not supplying power to the transfer bus. The switch below the lights allow you to turn the generator on or off. Now this is not the same as the red guarded switches above. Think of these generator switches as simple on-off switches. Think of the red switches above as the generator normal, generator destroyed switches. Once the engines are running, you'll flick these switches to the on position so that the engine generators become the primary source of AC power for the plane. In the middle we have an APU generator off bus light and two APU generator switches. So much like the engines, the APU can supply AC power to the aircraft as well when it's running, and you would turn the APU generators on and off with these central switches here. Typically, when preparing for a flight, an aircraft will use ground power when parked on a ramp. Then shortly before departures, the pilots will start the APU and then turn on the APU generators. This then allows ground crews to remove the ground power unit because electrical power is now being supplied by the APU. And then, after pushback and engine start, the pilots will switch on the engine generators and turn off the APU generators and turn off the APU itself. So now the aircraft is getting electricity from the engines. And then, after an aircraft has arrived at an airport, pilots would normally reverse this process to get back to working on ground power. Speaking of the APU, the last section of this panel all relates to APU operation. So you'll see here that things are a little bit cramped and disorderly, but let's take a look at it anyway. First, you have this blue maintenance light. This usually indicates that maintenance is required on the APU, however it still can be used safely. Next you have some warning lights which indicate problems with the APU. First is a low oil pressure light, you have a general fault light, and also an overspeed light. Remember that an APU is basically a mini jet engine which sits in the tail of an aircraft. Beneath those lights is an APU exhaust temperature gauge, and to turn the APU on and off, you use this switch down here. So APU operation is fairly automated. To turn on the APU, flick the switch down into the on position, and then press down for a second into the start position. The switch will then flick back to the on position. So as the APU begins to start, you'll notice that the low oil pressure lights will come on. That's normal and to be expected as long as the light doesn't stay on. You'll also notice that the exhaust temperature gauge begins to rise. Now if there's any other fault, the relevant warning lights will come on and the APU will automatically shut itself down. Once the APU is running, to turn it off, simply move the switch back to the off position. And finally, while we're down here, we have two windscreen wiper switches, basically two switches for the left and right windows, allowing you to select varying wiper speeds. So moving on to the next column, which thankfully isn't too busy compared to the first two. Up top we have two rotating switches, one for the backlighting on the circuit breaker panel behind the first officer's seat, and the other for backlighting on the overhead panels. Next we have our equipment cooling panel, which controls cooling fans for the flight deck systems, much like fans in a computer for example. There is a supply and exhaust fan, and these switches allow you to select alternate fans if the normal ones fail for any reason. There is also a couple of indicator lights to show when there's a problem with either the supply or exhaust system. Next is the emergency lighting and passenger lights. First we have the emergency exit light switch. Normally this is put into the armed position, which will automatically turn the emergency lights on in the event of an emergency. The off and on position allows the pilots to manually turn the emergency lights on or off, but as I said, normally it's in the armed position. Also, if you close the guard on the switch, it will move the switch into the armed position. Next to that switch you have a warning light indicating if the switch is not in the armed position. Below that you have a couple of passenger sign switches. On the right is the typical seatbelt sign. In the off position, the seatbelt signs are off, surprise surprise. In the auto position, the signs automatically switch on or off depending on the phase of flight, and the on position is simply on. On the left used to be a no smoking sign, however smoking is banned on all flights to my knowledge, so this has been replaced with a simple chime as a way for pilots to get the attention of flight attendants. Below you have a couple of buttons which serve a similar purpose. First is the attend button, which indicates to flight attendants that the pilot is trying to call them using the intercom system. Next to that is the ground call button, which sounds an alarm in the wheel well of the plane, so ground crew know that the pilot is trying to call someone on the ground. Beneath that is a blue call button, which lights up when a flight attendant or a ground crew member is trying to call the pilot. And finally we have a PA in use light, which is fairly self-explanatory. Moving across to column 4 now, we start with some anti-ice systems. Up top we have some window heat switches which relate to the flight deck windows. So there are 4 windows which can be heated to prevent icing from occurring, and they have some simple on-off switches here and a corresponding on-off light. The switch in the middle is simply a test switch which allows you to test the on-off lights and also the overheat warning lights. Beneath that you have probe heat switches which electrically heat various pitot tubes, temperature probes and alpha vanes attached on the outside of the aircraft. These lights indicate an issue with a specific probe. When the probe heat switches are on, these lights will extinguish. If the probe heat switches are on and you still get a light, then you know you've got a problem. Next we have more anti-ice controls. First on the left is the wing anti-ice system. So anti-ice protection in this aircraft is done using hot bleed air which comes from the engine, and the air is fed into the leading edge slats on each wing. Simply toggle the switch on or off to enable or disable the system. Also notice that the lights work the same way as the fuel pump lights. When the bleed air valve is moving, you get a bright blue light. When the valve is open, the light goes dim. And of course, when the valve is closed, the light is off. Next to that, you have the engine anti-ice system, which also uses hot bleed air from the engine. This feeds hot air into the engine cowl, the front rim of the engine around the main fan at the front of the engine. Again, you have a simple on-off switch, one for each engine, and blue lights indicating bleed air valve movement and position. There are also two orange cowl anti-ice lights, which will indicate if there is a problem with the system. Moving down, the next panel relates to hydraulic pumps in the aircraft. Now, hydraulics are important because they drive a lot of the moving parts of an aircraft, such as the ailerons, the elevators, the rudder, the flaps, the landing gear, etc. In the 737, there are two hydraulic systems, A and B. These have two hydraulic pumps per system. One of the pumps in each system is driven by an engine, and the other is driven by an electric motor. So on this panel, you have simple on-off switches to turn the pumps on and off. You have low pressure lights for each pump to indicate when the pump is producing low hydraulic pressure, normally means there's a fault. Also, for the electric driven pumps, you have an overheat light. Next, you have the aircraft door annunciator lights, which will light up when one of the doors on the aircraft is open. Very simple. And then below that, you have the cockpit voice recorder panel. Doesn't do anything in the sim, however you can test the system and get a little confirmation light. I believe this black thing in the middle here is the actual area microphone, and there's also an erase button and a headset jack for maintenance to listen to test sounds and also actual voice recordings from the voice recorder. Underneath that are some instruments for measuring pressurization within the plane. This first dial actually has two needles in it. The larger outer needle indicates the pressure difference between the inside of the plane and the outside. If this pressure difference gets too high, around the 9 psi mark, then there's a danger of structural damage occurring. The inside needle shows what altitude the cabin is at, so what altitude or air pressure is inside the aircraft. Now this changes to ensure that the pressure difference inside and outside the aircraft is always kept below that 9 psi mark. So in this example, the aircraft is climbing to 37,000 feet. The pressure or altitude inside the aircraft is equivalent to approximately 7,000 feet, and the pressure difference inside and outside of the aircraft is 8 psi. Another instrument below that shows the rate at which the cabin altitude is changing, so whether the cabin altitude is climbing or descending. In this example, the cabin altitude is climbing at 200 feet per minute. Next to those dials you have a button called Alt Horn Cutout. If there's a problem with pressurization in the aircraft, an alarm will sound for the duration of the issue. Now this can be distracting to pilots, so once they've identified the problem and taken action to resolve it, they can press this button to cancel that alarm. And finally, on the right hand side we have a few more panels which all relate to air pressurization systems in the plane. First though, I'd like to show you a basic overview of how the air conditioning system works in this aircraft, which should help in understanding the various switches and lights on this panel. During a flight and under normal operation, everything starts at the engines. Some very hot, high pressure air is taken from the engine, and this is called bleed air. This hot bleed air then goes into a system called a pack, which is short for pneumatic air cycle kit. What this does is to cool the air to near freezing temperatures, and it also dehumidifies it to remove all of the moisture. This cold, conditioned air is then sent into a mix manifold, where cool air from both sides of the plane are mixed, and then it is sent into the cabin so passengers can breathe. Now, of course, there's more to it than that, and I'll expand this diagram as we go. So coming back to the overhead panel, first we have a temperature gauge and a source selector switch. So by moving the selector on the right, this allows you to monitor the air temperature in various places of the air conditioning system. Here you can check the temperature of the cabin and also the pack systems. Next you have the trim air switch. What the trim air system does is help regulate the temperature of the air which enters the cabin. Let's go back to the diagram quickly. Remember what I said about air coming from the packs, how it's near freezing temperature? Well, that air needs to be warmed up before it's fed into the cabin, otherwise planes would be freezing cold. Now, it does get warmed up between the pack and the mixed manifold, but trim air is used to fine-tune the temperature. Some of the hot bleed air from the engine actually bypasses all of these systems and is reintroduced to the airflow just before it enters the cabin. Now, by controlling how much bleed air is mixed with the colder air, that allows you to regulate the temperature of the air going into the cabin. Anyway, moving on from the trim air switch, we have these three controls which are temperature selectors. So the cabin is split into three distinct areas or zones. You have cont cab, which I think is short for control cabin, basically the cockpit or flight deck area. Next is the forward cabin, the front half of the passenger cabin, and then the aft cabin, which is the back half. In the auto position, onboard computers automatically regulate various valves within the air conditioning system to automatically regulate temperature within the aircraft. However, pilots can also manually select the temperature. The coldest setting is approximately 18 degrees Celsius, and the hottest is about 30 degrees. Above those temperature controls, you have a zone temp light, which typically comes on if the air entering the cabin is too hot. In some circumstances, they can also indicate a problem with the temperature control computers. Now, let's move down and have a look at some of the bleed air controls. So at the top, there are some indicator lights which I'll come back to in a minute. First, let's look at these two recirculation fans, and it's best to bring back the diagram to explain this. So when the recirculation switches are in the auto position, this will enable the recirculation fans which take air from the cabin and feed it back into the mixed manifolds to be fed back into the cabin. The benefit of this is that it reduces the amount of bleed air needed from the engines, and it also reduces the amount of work that the packs have to do to introduce new air into the system. Next, I'm going to talk about the pack switches here. So as you might guess, this controls the packs and the speed at which they operate. Normally, when packs are working, they are set to auto. In the event that only one pack is working, that would then be set to high, and that can provide enough air for the plane by itself. This gauge above the switches measures the pack duct pressure, and there are actually two needles in this gauge, one for the left pack and one for the right. Now remember that packs cool the air. They do this by taking air from outside the aircraft and feeding it into the pack system. The air enters through a ram air inlet, which sits just in front of the wings on the bottom of the fuselage. This kind of works like the radiator in a car. Cool air passes through the inlets, or the holes in the front of your car, and hits a heat exchanger, or radiator, to cool the liquid which is passing through the radiator. Well, that's what a pack does. Behind this inlet is a heat exchanger which cools the hot bleed air. This is where these ram door lights come into play. When the inlet is fully open to maximize cooling, the inlets will be open fully. When the aircraft is in flight and air is entering the intakes at a higher speed, the doors are partially closed because not as much air is required for cooling. Now the next switch I'm going to talk about is this isolation valve switch. Remember when we looked at the fuel system, how there is a crossfeed switch to link the left and right fuel systems? Well, an isolation valve pretty much does the same thing with the bleed air duct, so that allows bleed air to pass from one side of the plane to the other if there's an issue. Just for clarity, the bleed air duct is the bleed air pipework which sits between the engines and the packs. Think of the isolation valve as a bleed air crossfeed valve. Next we have some warning lights and a couple of buttons. So first are the pack warning lights, which indicate when there's an issue with one of the packs. Next are the wing and body overheat lights. If there's a leak in the bleed air ducts, the very hot air which is passing between the engine and the pack, then it will trigger temperature sensors and these lights will come on. You can test these lights with the overheat test button up here above the right pack switch. Lastly, you have the pack trip off lights. So if the bleed air being supplied by the engine is too hot, then the bleed air valves will automatically close and no bleed air will pass into the pack systems, and the pack trip off lights will come on. Now this is not the end of the world, because you can just give the pack time to cool down before starting it again. You can also reset the system by pressing the trip reset button, but you'll never need to do that in normal flight. Finally, at the bottom you have 3 switches. These 2 are engine bleed air valve switches, which open and close the engine bleed air valves, and the one in the middle is for the APU bleed air valve, because the APU can also provide bleed air to the aircraft. When you have both the engine and APU bleed air valves open, you'll also see this dual bleed light come on, indicating that you are taking bleed air from 2 different sources. Now, in the bottom right, we have the cabin pressurization panel, which regulates the cabin pressure inside the plane during a flight. At the top are a row of lights. Now, the first one is an auto fail light, so if the automatic pressurization system fails, this will light up. The second one is an off-schedule descent, which lights up if the plane begins to descend before reaching its planned altitude. The next 2 lights are green lights, which come on when the alternate system is activated, and this is just a backup automatic system, or when the pilots are manually controlling the cabin pressure. Just as a side note, pilots can select between automatic, alternate, and manual control using this selector switch here. This here is your flight altitude selector, so you would dial in your cruising altitude before the flight, so the automatic system can control cabin pressure accordingly. Below that you also have the landing altitude selector, again so the automatic system can calculate how to manage the cabin pressure. On the right we have a little indicator for something called the outflow valve, which allows air inside the cabin to escape. This helps to regulate air pressure inside the cabin and is automatically controlled by the pressurization computers. However, in the event that pilots are manually controlling air pressure, they can open and close this outflow valve using this switch. Okay, we're almost there, guys. The next panel we're going to look at is mainly light controls. At the bottom, starting on the left side, we have the landing lights. So as you can see, there are 4 switches. The 2 on the left control the landing lights, which fold out from underneath the aircraft. They have 3 positions: up, where the lights are stowed; extended, where the lights fold out but are not switched on; and then on, which turns these lights on. The other 2 switches are for the fixed landing lights, which sit in the leading edge of the wing and don't move. You can switch all of these lights on with a single left click of the bar above these switches, or you can turn all these lights off with a single right click of that same bar. The next couple of switches are for the runway turn-off lights, which point out at an angle to each side of the aircraft. These lights sit next to the fixed landing lights in front of the wings. The next switch is the taxi light, which enables the light on the front wheel landing gear. The next switch is the APU switch, which we talked about before. After that we have some engine start switches. In the middle we have the engine igniter selector, which selects either the left, right, or both ignition systems within an engine. As for the engine start selectors themselves, obviously there's 2, one for each engine. Setting the switch to the ground position will initiate the engine start process. That involves moving various bleed air valves so bleed air from the APU can start spinning the engine to its idle speed. There's also arming the igniters in the engine to start working when fuel is introduced. The off, continuous and flight settings offer varying degrees of igniter activity to ensure that the engine continues running when extra stress is expected for the engine. An example of this would be flying through heavy rainfall, where the increased amount of water poses a danger to the combustion process inside the engine. Moving over to the right, we have a few more light switches. First is the logo light, which lights up the aircraft's tail, where an airline normally has their logo. Next you have the position lights, which are the red and green wingtip lights. This switch actually has 3 positions. Move the switch down to turn on the steady lights. Move the switch to the middle to turn the lights off, and then move the switch up to turn on the steady coloured lights, but also the bright flashing strobe lights. The next switch is your anti-collision light, or your red beacon light. These lights sit above and below the aircraft, and this tells ground crew to stay away because the engines are either running or they're about to be started. Next you have the wing lights, and these turn on small lights which illuminate the wings. This allows pilots and ground crews to inspect the wings in dark conditions. Finally, you have the wheel well lights, which help ground crews examine inside the wheel wells under the aircraft. Then finally, just underneath the overhead panel, you have a simple magnetic compass, which also comes with a light switch. And that about does it for the overhead panels. Now, rather than complicate things and bore you completely to death with one long video, what I'm going to do is take a break here and continue the cockpit familiarization in another video where we'll look at the various switches and displays which sit in front of the pilots. As I said back at the start of this video, this is a very comprehensive aircraft, but I hope that this first video has helped you get some insight and understanding. Once we're done with these flight deck videos, you should feel very confident moving through the procedure guides, where we'll take the aircraft from cold and dark to being powered on, and then through the various pre-flight procedures and so on. And if you've made it this far, I salute you. Anyway, thank you all very much for watching, take care out there, and I will catch you all later.